Use Python for everything. That's the message I want to get across in this video because I think Python may be the most unique language to come along in my career. And I'm going to talk to you why it is so and why I think you can now use one language to do everything. So let's jump in. This is, by the way, part one of a series. I'm going to talk to you about what we'll cover in other lectures or discussions. So where are we going in this video? I'm going to talk about Python as the silver bullet. Why Python? Python by application type and limitations. So I will actually admit it's not perfect for everything. If you go back a ways, like I do, there used to be something they used to call the silver bullet. I don't know what the new term is, but it was the idea of the silver bullet was that IT has this huge monster on its back, all these different business requirements to do all kinds of things, databases, applications, reporting, etc. And so it was kind of like the werewolf, right? This monster. And the idea of the silver bullet was that there was one tool that could take care of all of them and end the problem. That goes back many decades, mind you, a few decades at least, and that silver bullet never emerged. The idea of one solution for everything just never came about, and paradigms came across like case tools and packaged software could do it all and all these different options, but there was no silver bullet. In recent years, we've seen a proliferation of programming languages, and each one seems to come along to address a problem that another language created or didn't do well. And the frustrating thing I think about it is that very often a language comes along, we'll say it's Rust or something, and it does certain things really well. But then programmers that use it will say, oh, it's too slow maybe in accessing databases. I don't like that, and I don't like the syntax. Or maybe it doesn't use a procedural programming paradigm. So I'm going to scrap that and write my own language. I'll call it Brian Script. And Brian Script is going to do all the things the way I like it done. And by the way, it solved the original problem. Maybe it's got great database I/O, but it's horrible in other areas. Maybe Rust was really good at doing object-oriented programming or doing GUIs or something. And guess what? My language is weak there. So what happens is programmers just keep creating new languages. The answer to a problem isn't solve the problem. It's create yet another language. And that's probably the next best language. We should call it YAL, yet another language, right? This is a problem we have. And when we look at things like JavaScript, which is really the taking of a language which has been around as long as I have almost, it goes back to the beginning of the internet when the only language you could run in a browser was JavaScript. And it was only really intended to do like little animations to allow you to have some maybe drop down listen forms to do a little bit of interaction in really pre-application days of the internet. So JavaScript was great for that, but it was not a language that was designed with the idea of enterprise applications. And yet it's been just extended and extended and extended. And perfect honestly, I kind of think it's like a hamster wheel in the middle of this massive infrastructure that you got to wonder, is it really the best language? But that is the most popular language competing right now with, say, Python. And by the way, I am drinking out of my Python mug, wearing my Python shirt, so I'm very Pythonic today. And let me continue here. Java is a great language, and it's been around a long time. But Java is moving more and more into the back end, and it's becoming pretty clear it's not meant to be a front-end application language anymore. It's also, most people consider it hard to program, it's complex, etc. I think it's a great language, but it is not, after all these years, it is not becoming the silver bullet. C++ is a truly compiled language. Java actually is not. It's basically goes through a conversion called converting to bytecode, and then it runs in a Java virtual machine to actually run your program, which is essentially a runtime. C++ compiles to a true compiled language, so it's extremely fast, and it gives you the benefits of object-oriented programming, but it's too hard to code and people aren't going to use it. Not to that level, not for everything. C# is Microsoft's answer to Java, and we have things like Ruby and R, which is great for data science, and Rust, and Scala, and Go, and Swift. All of these languages are great in their own ways. They do some things really well, but I don't think any of them are truly the silver bullet, the one language to rule them all. JavaScript is probably the one that's really doing the most in this regard, but it's not the right It doesn't seem to me like it is the language which is going to really solve all the problems. Some of them, like Swift, to me seem a little too aligned with a vendor, and therefore, are you really going to get sort of a broad sweep and objective sort of support for writing code, or is it going to be more Apple orientated? Go is Google's language. People like it. Now, a kind of a sad thing in some ways is that if you're new to this, or you're kind of trying to catch on to what's going on in the industry, what language should you learn? Unfortunately, all these languages have this cadre of extremely passionate people that tell you it's the language to go with, and they have all their reasons. But I'm going to tell you, controversially, I guess, no, none of these languages are go-to languages across the board. However, I think Python is. Now, why I think that is the next part of my discussion. Okay, so why Python? So I want to go back there for a minute. I think Python, I love this because, of course, Lord of the Rings, if you're not a nerd and you don't like Lord of the Ring, you won't get that. But I love the books of Lord of the Rings. So even if you don't do anything else, read those books. They're great. The books are actually even better than the movies. But the idea of the one ring that ruled all the other rings, the Python is like the one ring. It is the master ring that controls the other rings. And one of the really cool things about Python is it can actually absorb the functionality of other languages. For instance, JavaScript has some really great libraries that do all kinds of cool stuff in terms of the web and data science, whatever you want to do. And Python just writes wrappers around those, and boom, it can now do all those things that Java could do. It supports Bootstrap. It's kind of like Rogue, and I've said this I think in another video, kind of like Rogue in the X-Men. Rogue had the ability to touch another person and then absorb their capabilities. Python does that. Python's very fluid and very good at wrapping around, just like the snake, right? Wraps around something and then takes its abilities and absorbs it into its own. So that's one of the great things Python. Let me talk about more things about Python that make it the go-to language. This is really good for if you're in IT management or you're responsible for budgets and things. Good time to really tune in here. Actually, the non-glamorous aspect that doesn't get as much attention in the media unless you get into Python is that it's really focused on maintainability of code, really lowering the cost of maintaining code. Now, here's a thing programmers don't like to admit, but most of us programmers, we're maintaining existing code. Somebody wrote it before. We love to write new code, but you can't always be writing new code. Somebody's got to go back and fix and enhance the code that's been written. And probably 80% or so of the code that programmers work on is maintenance of code that's already been written. What does that mean? It means that you need to be able to go into something that somebody wrote 10 years ago, maybe 20 years ago, isn't around, and you're trying to figure out what this code is doing and how do I work with it, how do we change it without breaking things, and that's maintainability. Python was written with the number one goal, really, the thing when people talk about being Pythonic, is clarity. Being able to read the code and really understand quickly what it's doing. That makes it cheaper to maintain. Now, that thing I wrote, PEP, there's actually a whole set of standards around Python called the PEP standards, which are how you should write code so that it's easy to read, easy to maintain, and you don't get yourself into traps that programmers typically do. So that's a really key area that IT management needs to catch on to because it's going to lower cost the more you can use something like Python. The next area that's really important is extensibility. Now, I love the extensibility of Python. It's like being a kid on Christmas over and over again because there's all these libraries everywhere. Oh, I want to do a web app. Ah, look, there's a great library for that. Oh, I want to do a mobile app, or I want to do, some application. I want to do games. Boom, there's an app out there for that. It's very much like if you have a phone like I do, a smartphone, there's an app for that. And that's how Python is designed. There's an app for that. They call them packages. And the packages extend the functionality of Python to do all kinds of things. Now, to give you an idea, I think a pretty good example of this, if you were to tell somebody, say 12 years ago, I'm going to do data science and statistical analysis using Python, you'd probably get laughed at. Python has all these complex objects. They take up a lot of memory and it's not that fast and things like that. So it would not be used for any kind of data science. One sec. But what happened was somebody said, well, where is the bottleneck? Where's the problem? And this is one of the brilliant things of the Python community. They never want to scrap Python. They love it. So they say, how do we solve the problem? Let's not scrap it and write YAL. Let's keep it and make it better. So in this case, it didn't do number crunching really well. If you gave it like a list of 10,000 numbers and you needed to have it churn through that list and create standard deviations and statistical analysis, on and on, handling arrays of numbers was a weak point because it was just too memory intensive and too slow. So somebody came along and wrote a library in C and then interfaced, wrote a wrapper around that library. They called it NumPy. NumPy is an extremely efficient and fast number crunching package that you can use from Python, and you use it and you don't even know you're using under the covers, but that's what it's doing. So now Python is one of the best number crunching languages there is, but it really isn't, right? Also, someone looked and said, R's got this great feature. It's called data frames. And what a data frame is, it's like an in-memory table, right? You get rows and columns, you suck it into memory, and you can sort and slice and dice, and it's great. Wouldn't it be great if we had that in Python? And so someone came along and said, excuse me, and they decided to write a library that does exactly that. It's called Pandas. So Pandas is panel data is what it stands for, and it's basically those like a spreadsheet in memory. You can work in number crunch, etc. And common theme, it works with NumPy for number crunching, so you get a kind of hybrid approach to the two, and now you have the same kind of data handling capabilities that R has, but it wasn't built into the language. Then someone said, we need data science libraries. So someone added some things like scikit-learn and a bunch of other things. And now it's even got PyTorch to do deep learning neural networks and on and on. And what about visualizations? Well, you've got Matplotlib and libraries like Seaborn, which give you all these capabilities. So with all these libraries added on, you end up with the functionality of something like R. But it's nothing like R. It's not even half as good in the base language as R is. But all these add-ons, all these extensions and add-ons takes this little thing and makes it very powerful. And that's what makes Python so amazing. Other languages, including R, can do that to a point, but nobody does it like Python. Flexibility is another thing I find intriguing about Python. Many people, when they want a language, say like Scala, it's a procedural programming language and they're dedicated. It's got to be procedural. You've got to have functions that when you pass it in, you get the same thing back if you give the same parameters and all these rules. Well, Python can do procedural programming. It treats procedures or functions as first-class objects. They can be passed around and treated as objects, but it also supports object orientation the way Java does. And it also, if you just want to write simple drop-through scripts, you can do that. So you have that great deal of flexibility and extensibility. More than any other language, and really I could say this in the history of that I've been working with programming, I've never seen so much passion and excitement among Python developers as in other languages. Yeah, some people are excited about Rust, some people are excited about C# or whatever, but Python is just unreal how excited and how into it are. And that is great because it means that when a newbie comes along, Python is one of the only languages where people are like, yeah, what are you trying to do? And they don't kind of criticize you. They don't say, oh, you don't know what you're doing. They actually say, yeah, okay, what you do, well, you need to do this. I totally get where you're coming from. And so you kind of feel like you've got this, it's kind of like a group therapy support in Python. People understand, they're not stuck up, they're not, uptight. I think in some languages, we'll say C++, for example, you kind of get the Sheldon Cooper viewpoint where I know all this stuff and you're a mere mortal, and if you can't program at the machine level, then you don't deserve to be here. You don't get that kind of attitude with Python, which again adds to the excitement and people are into the community. And because of the other features, it just makes it all the better. Now, when I started programming Python, I said to a friend of mine, I'm working with Python programming. And his reaction was, why? Python's glue. You don't program, you don't write things with it. It just connects things. And I realized like he wrote scripts that did some automated, or what I like to call it, Python is like duct tape, right? Because I tend to, when I can't get something to stick together, I'll just duct tape it. And it's kind of the another go-to thing. The surprising thing about Python, after all these nice features, is that it's one of the easiest programming languages to learn. It takes a lot less lines of code to do a lot of work. The way it can leverage libraries kind of extends the language itself. So you can do many things with only a few lines of code, which is very gratifying to people learning a language for the first time. They're not hammering away learning really useless little tidbits of information before they can do something useful. However, Python is easy to learn, difficult to master. The good news is you do not have to master Python, but I have a book that's like 1,000 pages and it's all about Python and the nuances and all these things. I think it's called Fluent Python, and it gets into all kinds of areas, which is good to know, but not necessary to just do your work. So that's kind of the nice thing too. You can go as deep as you want, but you don't have to. Finally, Python is platform agnostic. It can run on Windows and Linux and Apple and whatever. It works everywhere, which is really nice. It doesn't even have sort of a favoritism. You might think some languages tend to favor certain platforms. You don't see it like a bias per se, but you sense it. But in Python, you don't. You see a lot of cases where they go to a lot of great lengths to make sure Python will run, for instance, on Windows. And there was even an version, I don't know, called IronPython, specifically committed to using .NET, etc. But so it's really platform agnostic, and that's a great feature. Now let me just click here for a minute. This is PyPy. A lot of things with Python, by the way, if you take away nothing else, is you'll see py and then something. Py is Python, so you see PyPy, PyCharm, Py this, Py that, and that means it's related to Python. This is the Python most important repository. It's kind of central repository. So when you want to install a new package, you use a command called pip, which brings it from the pip repository, Python PyPy repository. But notice in this repository we have over 250,000 projects going on, over 2 million releases, all these files, and look at all these users, 500,000 users, and all these projects, etc., going on. And I can go in here and just browse projects or search for something, and you see there's frameworks and all kinds of topics within this. So Python is just a massive library. There's nothing like it. R has a pretty good one they have called CRAN, a lot of good features, but R is really focused on data science and machine learning. Python is kind of an all-purpose do everything language. So let's talk about Python apps. The first app that you may want to think about doing, you say, well, Brian, can I use Python to develop web applications? And the answer is yes, you can use it for that. I'll talk about a number of frameworks. I'm not going to get into any details here, but there are a lot of different packages and things that you can use to help you do web and mobile development. Also has one, there's a built-in library called Tkinter, which allows you to do complete GUI applications without downloading any packages. It's built into what you get with Python when you install it. Now, it's pretty much ubiquitous using for data and AI these days to use Python. It's the go-to language really next to R. They're both very heavily used. But Python is really just taken off. It's the best language I think to use on, for instance, Apache Spark for big data. It has a lot of machine learning libraries, and so it's obviously very big there. Automation. I use a lot of PowerShell. I've got a whole bunch of PowerShell videos. Some people like to use bash scripts to do things, whatever your preference is, but Python is a really good choice for doing automation. And again, a lot of the functionality you need is already built into the language, but then there are packages which extend it. You might be surprised to learn that you can actually write games in Python. Now, it's a great example of where you run into bottlenecks and then developers figured out how to fix the bottlenecks in Python. When you're doing games, it's a lot of moving graphics fast, and that's very memory and CPU intensive typically. However, Python has libraries which take care of those parts of it so it moves really quickly, and then the parts that are less critical are still just in good old Python. So you have libraries for that. And of course, as a student language, you'll see lots and lots of tutorials, you'll have videos on YouTube, everywhere. I've got a bunch of them related that teach you how to program now with Python, and it's a great starting language because it has a lot of simplifications that you don't have in, say, Java. For instance, the dynamic data typing and simplicity of the syntax makes it a lot easier for people to pick it up, and you get to do a lot of fun stuff without having to wait for years. You don't spend 10 years as a Padawan before you get to be the master. You get to do stuff that the masters do early. Now I will talk about each of the application types in a separate video. I've already got one I'm working on for the web app one, where I'll get to tell you what libraries you can use and what the pros and cons of each one are, and you'll get into that. Suffice it to say that the challenge is not so much finding a package that can do these things, but figuring out which one is the best one to use for your needs. So hold on for that, and we will get to that. Finally, I'm going to wrap up with limitations. Everything is not perfect. Python is not a perfect language. So in this regard, I want to relate a story. A few years back, I'm not a good golfer. I'm a horrible golfer, and I kind of gave up golf just because I'm so bad. But when I did go, I went one time with a friend of mine, and he noticed that every time we came up to a hole, I would just pull out the 5 iron, and he started making a joke of it because it's like, looks like a difficult, shot here, Brian. Better use the 5 iron. Then we'd get to another place. Better use the 5 iron, and it was kind of an ongoing joke. Now, if you've golfed at all, the golf bag has like a myriad of clubs, and the really long ones that have a big like ball at the end basically is the wood, and that's meant to really uh, hit a driver. It's the one that you use to tee off, where you try to get as close as you can to the hole. The pros, they can do it one shot and get there. Then you get the medium range clubs for when you're already on the fairway, and those are the irons, and the 5 iron is in the middle of those. So for really short distances, you would use the higher numbers, and for the longer ones, the lower numbers. I believe that's how it goes. So the 5 iron is kind of in the middle, and it's one of the easiest clubs to hit with, which is why I use it. And then you have the short range clubs like the putter and the pitching wedge for sand traps. Now the point here is Python is kind of like that 5 iron. It doesn't do every task well, but it's in the middle there where it can do pretty much everything. And in some cases, like in the case now with all these libraries for data science, it actually does it extremely well. It's like a versatile club. You can just switch things out when it comes to data science. In other areas, it's evolving. So the takeaway from this is, if you're looking for that best in breed approach to IT, Python's not it. Now, what do I mean by best in breed? Well, imagine you have, we'll say, I have one car. We have two cars, we'll say. We have one that's like a RAV4, and then we have another one which is, say, a Toyota Corolla. I actually think mine's a Nissan Stanza, but okay, you get the idea. So you get these two different Altima, I should say. So we got the two cars. Those cover my needs, right? If we need some more space, then we use the RAV4. We got lots of room. We can put things in it. And when you want to just go on a quick ride and you don't want to pay as much gas, then you use um, the smaller car. We'll say Toyota Corolla, whatever it is. That makes sense, and that's a typical scenario. But you might have someone who's like Jay Leno, who's got this entire garage full of all of these different cars, really fancy cars, the Rolls Royces, the Maseratis, all these different cars. And each one, he wants to drive just a specific thing. It's the best car for a situation. Well, it's very expensive, but he does have the best in breed. And that's kind of what you do in IT. If you say, well, for our databases, we're going to use only Oracle, which is very expensive, and we're going to use only these tools and all these monitoring tools for Oracle, and we're going to use this elaborate system for our security, and our languages are going to be Java for this and X for this and Y to that. Now, yes, you can do that, and you will get the best in breed. You'll get those kind of perfect solutions, but it's extremely costly. And if you're in business, you don't want to spend all your money just writing software. So Python is not that. Python is the first case. It's more like you got your RAV4 and you got your Toyota Corolla, and you can cover pretty much everything you would need. But yeah, it's not the Taj Mahal in terms of accommodations. Which means it comes back to this too. It may not meet your needs in all cases. Now, when I say use Python for everything, I don't mean literally for everything. I can accept that there are going to be cases where you really need to do some other things. If it doesn't meet your needs, you can always identify where the problem is and then write a library either in Python or another language and then interface to it. Or you may decide that in some cases, say you want to write a mobile app, for example, and you really want it to be just perfect and it's critical for the mission of the company, then maybe in those cases, you just say we're going to write it in something else. Now, having said that, I think there is a real value to trying to go into like a 90% Python in a shop, because you can keep the simplicity of your environment down. You can require less technical people. You don't have to hire resources with these ridiculous, you see these now, all these jobs, and they list like an alphabet soup of requirements, and everybody's got to have 30 years in tools that have only been around 5 years. You see that all the time. And the problem is that managers don't know what to ask for anymore. They just want everything because they don't know what they have or what they need. We might have C, we might have Python, we might have this. So if you can get down to like a 90% Python, then most of the time all you really need to do is look for Python developers, and you only need one or two people who can do some of those C things or whatever. So again, really good. Now I mentioned mobile computing and having a language run in the browser. Python does not by default run in a browser, and Kivy has come along as a mobile app development platform or framework, but it's still evolving, so it's not necessarily the best for mobile development. Now I talk, and as far as running in browsers, there is an answer I'll talk about in my web development video called Anvil, which lets you pretty much run Python in a browser. So it's kind of cool. The biggest weakness to Python, one that really made me not want to learn Python, was the lack of strong data typing. What do I mean by that? Well, when you have data, it's important to make sure you get the right type of data. It's critical to any application, right? So if I'm collecting, customer name, their address, their birth date, their age, salary, or whatever it is, I need to know that the age is stored in a numeric column. So I'll type it. I'll say that's an integer. It's whole numbers, right? I want the birth date. It's a date type. I want to know, are they married, not married, or whatever. I can say it's a Boolean, yes, no. And all these types, once defined in any language, most languages, like even PowerShell, or if you do use strong data typing in PowerShell, which is optional, or C or Java, or even Visual Basic, will enforce that type. Unfortunately, Python does not, or did not until very recently, have that. So if you don't have that, then the problem is it's not enforcing any data types. Python will let you throw anything and anything, so you can end up with a name in the person's age column. And it can cause bugs, of course, down the road, which can be difficult to fix or track. The good news is, as of Python 3.6, they have added strong data typing. So I was surprised and happy to see that. I'm not sure exactly what version of Python we're up to now, but as time goes on, it's pretty clear they're going to extend that by having enforcement of the types. So yes, now you can say it's an int, but it's not going to do anything to stop somebody from putting a string in it. However, as time goes on, it looks like Python's going that way, and I think that's really critical for those big enterprise applications. So as that gets rolled out in Python, it's going to just build an even better case for using Python. Now, as I mentioned, Python is not the best language for performance, so identifying bottlenecks and writing things around it is the best approach to solving that. If you really need a lot of those types of places that you'd have to patch, then maybe you do use a different language like C++ or something. If you need low-level control, that's a good place where you might want to say, yeah, we should write it in something like C that can get into the computer's memory, manipulate registers. Most places don't want you to do that now because of security issues if you start to do that, but there may be reasons where you need to. And I want to say finally, beware of Python's sort of, people who are listing the disadvantages and problems with Python. Number one, some people are just biased, and so that can be a problem. But two, and the more important one, is that Python is quickly changing. It's moving so fast. Things that were not available just a year ago are now out and really good. And I've been seeing a lot of things. I've recently been focusing a lot on Python on Spark. And in just a matter of months, things have moved to greatly improve Python's performance in Spark. And that's happening in a lot of places. So make sure when you're trying to evaluate Python, you do it with recent information. I also saw some critiques. I looked online to see what other people said were negatives to Python. And sometimes I just really disagreed. One I saw was specific to that it wasn't good with database I/O. I don't really see that. There are a lot of libraries there. It has a DBA API interface, which can use ODBC and JDBC, and this critique actually said you can't use JDBC and etc. I think it's as good at connecting to databases, and I have several videos using SQL Alchemy or SQLite, but also DB API to interface with SQL Server. I don't have Oracle, but it could interface with Oracle, Postgres, MySQL. So as far as accessing data, it's great. So just be careful because you may see negatives that may not be 100% accurate, and so you want to watch that. And it may have been accurate at some point in the past, but it isn't anymore. So those kind of things you got to watch out for. So wrapping up, we talked about Python and the silver bullet, and my idea that Python is the one ring to rule them all. And then I talked about why I think it is the one ring to rule them all. And if just to highlight quickly, it is very readable and maintainable, which means lower costs for IT. Secondly, it's extremely extensible with massive libraries. We saw PyPy with all the things you can do. Third, it's just a really good language for so many different applications. We talked about Python application types, all the major ones that I could think of, and I'm going to go, as I mentioned, into separate videos, so look for links, and I'm trying to put one here if I get the other video out in time. But Python by application type, we're going to walk through. I'm going to do a video for each one to kind of talk about what libraries to use, how to get started, all that stuff. And I did admit the limitations. It's not perfect. It's getting better all the time, but there can be performance issues. The Dynamic data typing is still a bit of a problem. It also, some people don't like to. It has a tab. You don't put beginning and ends of blocks of code in Python. You just tab it, which makes it very readable. But it can also make it a little bit weird for people, because if you tab something, even a character off, Python doesn't like it, stuff like that. So that can be some of the limitations you should be aware of. So I hope you like this video, enjoy it. Look for my links. I'll put some links to other videos in here. Subscribe, share, let me know what you think. Thank you.